Assalamualaikum warahmatullahi wabarakatuh and good evening to our lecturer, Technologist Dr. Ahmad Suhaizi Matsu. We are from Group 1 going to do a title Design and Analysis of Lift Arm for 3-point hitch of tractor. This is review. So these group members consist of me, Ummu Qatrunnada Liyana BINTI Kamaruddin with metric number 192016. And
okay, my name is Mohammad Sollehan bin Mokhtar. My metric number is 200302.
My name is Dieli Cyril Emeka. My metric number 191503.
My name is Mohammad Ashraf bin Mohammad Nordin, and my metric number is 197864.
so I'm going to start the presentation first with our first part, which is the introduction. So for the introduction, this 3-point hitch, also known as the 3-point linkage, is a straightforward method of connecting any implement to the tractor. So the primary parameter used by manufacturers to define 3-point hitch performance is actually its lifting capacity. The main component system are tractor hydraulic system, lifting arm, leveling rod, lower link, and also top link. As you can see, Figure 1.0, the image of tractor hydraulic 3-point linkage system. We can see where spark is the top link, lower link, lift rod, and also the bell crank AC. And then proceed to the second part, which is the objective. So the objective of this review is to analyze the strength performance of the 3-point hitch system by using experiment tests. It also to estimate the stress distribution and any safety factor of lift arm. So for the background, the 3-point hitch, also called 3-point linkage, is a simple way of joining any implement to the tractor. The implement can be attached onto the tractor by one operator, as well as implement that are pulled. They can be lifted up for transport. So the 3-point hitch is made up of several components working together, and these include the tractor hydraulic system, lifting arm, leveling rod, lower link, and also top link. As already mentioned before in the figure 1.0. There are 3 movable arms in 3-point linkage, which is the 2 lower arms are the hitch lifting arm that controlled by the hydraulic system and provide lifting and also lowering the arm. So the upper center arm called the top link is movable, but it is usually not powered by the tractor hydraulic system. Each arm has an attachment device to connect implements to the hitch. So the problem statement. The problem statement here is that the hydraulic 3-point linkage system was introduced for lifting and lowering the implement at the headland and for transportation. The implement cannot be fixed in a constant position due to the large variation of the working depth of the plow on undulated soil surfaces. So to prevent this, a system variable is needed, which can be held constant by a closed-loop control system without the implement being in a fixed position to the tractor. So the pulling forces, also known as draft control of link, is the 3-point linkage system. The draft control system of the tractor is incorporated to automatically keep tractor effort constant by varying the depth of operation within narrow limits by bell crank assembly. So the FEM was used to obtaining maximum stress and fatigue analysis of connecting rod in the engine of MF285 and Universal 650 tractors. I'm going to pass to the next presenter, Mohammad Sollehan, to talk about the methods.
Okay, thank you, Ummu. So for the method that used for the design of the lift arm is mesh. Mesh is defined as the process of dividing the whole component into number of elements so that whenever the load is applied on the component, it distributes the load uniformly, called as meshing. So the type of mesh is a 3-dimensional. So the element of the 3-dimensional is hexahedron. Hexahedron is a topological cube, has 8 verticals, 12 edges, bounded by 6 quadrilateral faces. It is also called a hex or bricks. So from the slide, we can see at the above is the hexadron, the design of the lift arm. At the bottom, we can see the hexadron image. So we move to the next part. So the working process of this analysis is started by design of part in CATIA software. And then we move to the material selection. After we have select the material, we add the material properties to design the product. After that, we generate result using any software. And for the last is we compare the result with the previous results. So for next slide. So for the method that we use is a trial and error methods. So in the part one, we have 3 trial. So we move to the next slide. So for the part one, so the part one in trial one, the basic part is modified by adding slot on the middle horizontal surface of the lift arm. The trial two, the trial one part is further modified by increasing the width of the middle horizontal surface of the lift arm by 5 mm. So for the trial 3, the trial 2 part is further modified by decreasing the depth of slot from 7 mm to 5 mm as a result to increase safety factor of lift arm. So we move to trial and error part 2. So for the part 2 trial 1, this part was designed by modifying the basic part by providing elongate hole of length of 100 mm with the radius 12.5 mm. The depth of elongate hole is 5 mm. In the trial 2, the trial 1 part was modified by increasing the width of the horizontal surface of the lift arm from 30 mm to 35 mm. The elongated hole length is reduced from 100 mm to 80 mm, and the depth remain same. We move to part 4, trial 1. So in the trial 1, the part 3, the basic part was modified by providing support to the exterior end by extruding the rectangle of width 25 mm, and the length was extended till the next surface. In this trial, the trial 2, in this trial of part 3, which shape support was added from the rear ends till the middle of the horizontal surface of lift arm. The width of the wedge shape support is 30 mm.
So for the result, the table 1 properties of AISI 1020 material. So the material is AISI 1020. The temperature in degrees is 22 degrees. Then the Young modulus GPA is 186. Then the next one, Poisson's ratio 0.29. Then the bulk modulus is 148. Then shear modulus 72, density is at 7.87. So the analysis of details for part 1 is listed here in the table. Move to the next slide. Then also for analysis details for part 2, the analysis details for part 3 and analysis details for part 4. All the numbers are there for the analysis. Then move for the conclusion of the tables. Next slide. So for the analysis, for this AISI 1020 materials, 4 parts with 2 to 3 trials were taken. In part number 1, factors of safety was improved by changing dimensions and adding materials to design. Improvements done resulting safety factor from 0.85 to 1.31, which is good result compared to basic design part. And lastly, further improvising till the part number trial number 2, we got best result of safety factor 1.5208. Now, changing material is the most important. Next. So
Thank you, Emeka. I'm going to present about the safety measurement. As you know, safety measurement is very important during we operating the equipment, specifically on the 3-point hitch. So firstly is we need to stop the tractor and turn off the engine, as well as properly and safely parking the tractor. Then braking the tractor before connecting the 3-point hitch. This is for precaution step to avoid the damage to the implement. So next, we need to connect the draft sleeve to the connector component safely using pin size appropriate connector and clips. Next. So in the study, our conclusion is analysis solve was used to find out stress and safety factor value of lift arm of tractor 3-point hitch. Basic part with material AISI 1020 has safety factor of 1.106 at load of 30,980 Newton, i.e. 1,425.07 kilogram. This result is improved efficiently with material ASI 1040. Resulting safety factor is 1.5724. Also, deformation decreased from 0.00026.374 m to 0.0024484. Then, so this report conclude part 4 that used in this report is suggested for better load bearing capacity. Next. In this, this is our reference. First, we refer to the design and analysis of lift arm for the 3-point hitch tractor. Also, we also refer to the tractor hydraulic power data acquisition system, Department of Biological System Engineering. Lastly, we also refer to the durability analysis methodology of tractor hydraulic bell crank assembly for various agriculture operation, SAE technical paper. Next. All right, Doctor. That's all from us. Thank you.